and he decided that it was impossible to prove that it was impossible, that it was possible. He said, well, if not impossible, then can we show that it's unlikely? He said it was unlikely that it was unlikely. You can't show that it's unlikely. He says, well, if that's the case, then there is a good possibility that we're all living in a computer simulation. Okay, now Nick Bostrom was about a decade after Fredkin. Now last on my list is Brian Whitworth. Brian Whitworth then looked at this hubbub going on in the physics community of reality is a virtual reality that's digital and reality is objective. Of course, the objective one is the traditional view. And he said, well, let's just take those two and see which one answers, the data better. Let's look at all the things that we know about the world, the things that experiments have verified for us, and see which one of these theories does the better job. So Brian did that, and his answer, the last paragraph of his paper, and this again was a peer-reviewed paper in a scientific journal. His bottom line was, physicists, you need to wake up. The digital reality paradigm works a lot better. It's a better theory than the reality is objective theory. It answers the data better. Okay, so see, that's where we are now. Physics is kind of turning a corner. They're beginning to see that this is the nature of reality. Brian Whitworth has published, or is in the process of publishing, another paper. I think that's called Simulating Space and Time, and the preprint of that paper is up on the web. If you want to know that, you can send me an email, and I'll get you the link for it. Actually, I'll have the link up on my site pretty soon. Anyway, so he is generating the physics that describes the mechanism of how this physical reality can be generated from virtual digital simulation, how that happens. What's the physics of it? He's doing a very good job of it. All right, now we're going to get kind of away from science. I just wanted to give you that background to show that what we're going to talk about isn't just some airy thing that somebody thought up was kind of a cool idea, but this has a firm roots in science, and the idea is growing. Okay, so it's a whole new paradigm, a way of thinking about reality. Okay, let's talk about reality as information. Okay, at this point I'm going to start presenting a theory of consciousness and reality that solves the problems of physics and some of the problems of metaphysics, well, all the problems of metaphysics actually. One that unifies the normal and the paranormal and makes everything actually just normal. There is no paranormal. All of it's normal. All right. The larger consciousness system is a digital information system. That's a hard one for a lot of you to swallow, but let's go on. At the most fundamental level, consciousness is information. Okay? Information is bits. Bits are binary. Now, that seems really strange at first. How is this reality a digital simulation? But if you think about it, what is this reality to us? How do we perceive this reality? Through our senses. Well, what's that? It's data collection. It's just data. That light beam, bounces off of me, hits your lens, gets focused on your retina. The retina sends out a little electrical pulse. It's a pulse. That means discrete. That's what I mean by digital. Discrete. Comes in chunks, not continuous. Okay, so that little digital pulse then goes down your central nervous system, starts firing off neurons. So now you're getting patterns of neurons interacting. That's just data. It's digital data. So this reality already, even if you don't think about consciousness, if you just think about this reality, you'd have to come to the conclusion that it's just digital data that creates this reality. Well, what happens? You interpret that digital data, those patterns of neurons, those electrical signals, you interpret them as this. This is your interpretation. Well, how did you learn to do an interpretation like that? That'd be a pretty clever interpretation. You started when you were born. That's what you were doing when you were lying in that crib and the hand came up like this and you didn't even know it was yours, right? But eventually you figured out, oh, that's my hand. I can control that thing. And that's my foot, that thing I was sucking on, that's my toe. And you kind of figure these things out. And that's how you learn to interpret those signals. Because that baby's getting the same signals. He's having light hitting the retina, it's making signals, patterns of neurons, and he has to figure out what do those patterns of neurons mean and those signals. And he eventually learns it means this. So we're already interpreting our reality from digital data. Okay, now take just one step further. We don't need an objective world to reflect the light to produce the data. Let's say that we're just getting a data stream from consciousness. Say there's a larger consciousness system, it's sending us a data stream. And let's say that data stream would create the same sort of neuron patterns, the same sort of electrical impulses as does this light reflecting off of what we think is an objective world. Well, could we tell the difference? No. It's all the same. You know, the patterns of neurons are the same, the electrical impulses are the same, what we interpret's the same. So you see how it's not that big a stretch to realize that consciousness is digital, information is digital, this world is created by your interpretation of the data. That's what creates the world. Not a huge leap of logic. Okay, information is non-physical and subjective. Thus, consciousness as an information field is non-physical and subjective. And you're thinking, how can information be non-physical? There's informations everywhere. That's because we're very sloppy with the word information. Information is the meaning, the content, the message. Information is not the medium or the code symbols. So we take a book. Okay, a book, the paper is the medium. The words, the ink squiggles on the paper that are the letters of the alphabet, those are the code symbols. But that's not information. It's the content, it's the message, it's the meaning is the information, and that requires a consciousness. That book has no sense of the meaning of those words. A computer screen has no sense of the meanings of words. It's not until a consciousness sits down that it can extract information. So media and code symbols are just ways of storing and transmitting information. But it requires a consciousness to create, to write, and to encode that information. And it requires another consciousness to read, and decode that information. Information is non-physical. Anything physical takes up space and has weight, right? You can put it in a box. Can you put meaning and content in a box? Significance? No. It's non-physical. Those things are not physical items. You can put a book in a box, but you can't put content, meaning, and significance in a box. And that's what the information is. It's not the paper and it's not the ink. It's the content. All right. I think we've done all of that. Okay. Now, I'm going to talk about information systems and evolution. Okay. Information in a digital system is represented by organized bits. Now that makes sense, doesn't it? If you had a lot of bits and they're just random, what's the meaning? There is none. They're just random. It's not until those bits get organized that you end up with information. Okay, so you have to organize the bits in order to get information. That brings up a term called entropy. And in information theory, entropy is used a whole lot, and it's a measure of disorder in a system. Okay, measure of disorder in a system. So let me give you a couple of examples of entropy so you understand the term. Take a bunch of children, ABC blocks, and you just throw them in a random pattern. What kind of information do you get? That you have a naughty child, maybe. They throw them in a random pattern. But you don't get any information from the blocks because it's random. Arrange the blocks so that they spell something. Oh, now you've put order to the blocks, and now you've got some information. But it's not just language. See, pattern carries information too. Let's say we take those blocks and I put one down, one up, one down, one up, one down. Where's the next one? Up. How'd you know that? Well, because the pattern contained information. That's how you knew that. So see, it doesn't have to be language. Information comes in many forms. Any kind of construct, any kind of order, okay, can carry information. Now, entropy is a measure of disorganization. High entropy, high disorganization, high randomness. You can think in terms of signal to noise. High entropy, mostly noise. Low entropy, mostly signal. See the difference? There's another attribute of entropy, and that is that the lower the entropy, the more organization, the more power, the more energy, the more ability to affect something. And my example for that is, think of a bottle of gasoline. Take a bottle of gasoline, and that is very ordered. The molecules of gasoline, being the system, are very ordered. They're packed together very tightly. They have to relate to each other, very closely. It's an ordered system. You have liquid gasoline. Toss in a match, it can affect everything around it. Okay, it has power to do things. You can drive at least a couple of miles in your SUV with that gallon of gasoline.